Hello, algebra students. In this lesson, we're going to be learning how to solve something called a literal equation. Literally. All right, and what we're going to be doing in this lesson is solving equations that have more than one variable. What is a literal equation? Well, a literal equation is literally an equation that has more than one variable. And if you look down at the lesson practice examples, you'll see that that's the case. N in the same equation, X, Y in the same equation, F, C, we've seen this one before, the formula for converting Fahrenheit to Celsius. This one is F, M, and G. Okay, so there are equations that have more than one variable. Now, here's the thing. When an equation has just one variable, we can get that variable on a side by itself and associate a specific number with it. Or sometimes we realize there are no numbers to associate with it. Or sometimes we realize there are an infinite number of numbers that we can associate with that variable. But what we need to do is get a variable on a side by itself. This is going to be the exact same thing. We're going to be getting a variable on a side by itself. The difference here, though, is that we're not going to end with just a single number. We're going to find that our variable is equal to an expression that's made up of terms. And that's what we're going to be doing. So we're going to get the variable that's asked for on a side by itself. And then we're going to be able to state the expression in terms of that variable. Okay, so let's take a look at what we're doing here. Solve for n. N is the variable we have to get on a side by itself. So we're going to use the techniques that we've been using to rearrange this equation so n is all by itself on one side. Let's see how we're going to do that. So first of all, I'm just going to write my original equation. 3m plus 2n equals 8. And let's just note this is letter A just for the sake of keeping track. Okay, now I need to get n on a side by itself. So the first thing I'm going to do is subtract 3m from both sides. Because I need to get 3m off of the side that has n on it. And remember, the way that we do these equations problems is to do reverse order of operations. So first thing is going to be a subtraction and then a multiplication or division. All right, let's see how this looks. So I've gotten rid of my 3m. 3m combines with negative 3m to make 0. I still have 2n on this side equals 8 minus 3m. Okay, next I need to get n by itself. So that's going to look like this. N equals 8 minus, we're going to divide both sides by 2. I should probably state that, and then let's do it. So 2n divided by 2 is just n. I undid the multiplication by 2 there. And n is going to equal 8 minus 3m, and then we're going to divide that whole thing by 2. 8 minus 3m over 2. Now, I can simplify this one more step, okay, and I think I'm going to do that because I can. This is the same thing as, let's see, when I divide 8 minus 3m by 2, that's the same as multiplying the expression 8 minus 3m times 1/2 on the outside. This over 2 is going to distribute to this and to this, okay? So it's going to be 8 over 2 minus 3m over 2. Or the other way to think about it, if I have 1/2 out in front and this was in, let's say that this was in parentheses with a 1/2 out front, the 1/2 would distribute to the 8. The 1/2 would distribute to the negative 3m. So what is that going to look like? Well, it's going to be 4 minus 3m. There we go. 3m, and this is going to be over 2. And that's my answer. So n equals 4 minus 3m over 2. I could have also left it as 8 minus 3m over 2, but that's not algebraically in simplest terms. Okay, so that's the sort of thing we're looking for. Let's see if we could do that for letter B. We need to solve for x. We're going to get x on a side by itself. Well, this is going to be the exact same thing that I've been doing, except now I'm going to have a variable in my answer instead of just a nice, neat number. Okay, so let's see how this works. The first thing I need to do is get x on a side by itself, just like we did before. So I have x on both sides. I need to get my x term all alone. So I'm going to put a minus x over there, minus x over here. Let's see. So what's that going to give me? Well, if I go down to my next line here, this is going to be 2x plus 2y equals 8. And then the x and the minus x on that side cancel. Now I'm trying to get x on a side by itself. That's what it says. So the next thing I need to do is subtract 2y. I'm going to subtract my non-x term from both sides. Here, I'll just put it under the other 2y. Then I'm going to do minus 2y from the other side. What this is going to give me is 2x equals 8 minus 2y. Then lastly, I'm going to divide by 2, divide by 2. That'll get x all by itself. That's what I want. So when I divide both sides by 2, x is all by its lonesome on the left-hand side. X equals, this is going to be 8 minus 2y. And that whole expression there is going to be divided by 2. Let's see, let me fix there we go. Okay, so 8 minus 2y over 2. Now, can I simplify that? Well, if I distribute the divided by 2 to both of these, yes, I can simplify. So this is not in simplest terms. It's going to end up being 4 minus y. Divide the 8 by 2, divide the negative 2y by 2, 4 minus y. X equals 4 minus y. The goal is to get the thing that they're asking for, in this case x, on a side by itself. All right. Next, let's take a look. And I'm just going to work the next problem over here to maximize my space. Letter C. The formula for Fahrenheit expresses a Fahrenheit temperature in terms of a Celsius temperature. Find the Celsius temperature when the Fahrenheit temperature is 86 degrees. Well, here's the thing about this equation. If I solve it just as it is right now, it's going to be really annoying because I'm going to be plugging in 86 for Fahrenheit, but Fahrenheit's the thing I have on a side by itself. This equation is set up to calculate Fahrenheit if I'm given Celsius as an input. What I should do is get Celsius on a side by itself and then use Fahrenheit as an input. So, okay, how am I going to do that? Well, my equation is F equals 9 over 5 C plus 32. If I'm going to get C on a side by itself, the first thing I'm going to do is I'm going to subtract 32 from both sides. So I'm going to have F minus 32 equals 9/5 C. All right, now I need to get rid of this 9/5 over here. Here, I should also note that this is problem C here. There we go. Okay, I somehow need to get rid of my 9/5 that's multiplying my C. Well, that's pretty easy because I could just multiply by 5/9. Let's go ahead and do that. I'm going to multiply this side by 5 over 9. That's going to get rid of the 9/5. I'm going to multiply this side by 5 over 9. Okay, and the way I'm going to do that is I'm just going to say it's 5/9 times F minus 32 in parentheses. What does that leave me with? This 9/5 cancels out with the 5/9. So this leaves me with 5/9 times F minus 32 equals C. Or I can switch sides at any point. I can switch sides of my equation. So I could say C equals 5/9 times F minus 32. All right, now we can simply plug in F to solve for C. So this is going to be 5/9 times F is 86 minus 32. Let's see, 86 minus 32 simplifies to 84/54. Okay, 5/9 times 54. Well, let's see. I can, if it's 5 over 9 times 54 over 1, the 9 is going to be on the bottom. And let's see, I know that 6 times 9 is 54. So this 54 and 9 cancel out to a times 6. So this is going to be 30. Now, if you didn't follow that, that's okay. You could have just punched it into a calculator. But you should get 30 degrees Celsius as your answer for C. How did we do that? Well, we got C on a side by itself. Let's do letter D. Same situation, the formula for the volume of a rectangular prism with length L, width W, height H is V equals LWH. But I bet we're not solving for V. Find the height in inches of a rectangular prism with volume 6 feet cubed, width 12 inches, and length 24 inches. Okay, I spy a couple of problems with this one. I noticed that the width and length are in inches and the volume is in feet. So what we're going to do is we're just going to express width and length in feet because it's easy. 12 inches, 1 foot. The width is 1 foot. The length is 2 feet. So that one's going to be easy to compensate for. But first, we have to deal with this. Volume equals length times width times height. But we're solving for the height. So we should get h on a side by itself. What am I going to do? I'm going to divide both sides by LW. I'm going to divide this side by LW. Okay, so LW is the thing we're dividing both sides by. I should say it's the quantity LW, so it looks more like this. That might be a little clearer what we're doing. I don't know if I have to do that, but I'm going to put those in parentheses there. Okay, so what is this going to look like? Like this. V equals H, and then V is going to be over LW. Let me get a fraction bar here. There we go. H equals V over LW. All right, let's see if we can solve this. So H, my height, equals the volume of 6 feet cubed divided by the length, which is 2 feet, times the width, which is 1 foot. So the height is 6 divided by 2, or 3 feet, or 36 inches, however I want to express that. But that's the height of this rectangular prism. And then finally, letter E. The fuel economy rating of a vehicle is determined by the formula F, fuel economy, equals miles per gallon of gas, okay? Felicia's car has a fuel rating of 28 miles per gallon, so that's this. Her trip is 350 miles, that's this. How many gallons of fuel does she need? Let's get gallons on a side by itself. Now, how am I going to do that? Well, actually, I'm going to multiply both sides by G. If I multiply both sides by G, that gets G off the denominator over here and into the numerator. I need G in the numerator to be able to solve for it. So let's see what this looks like. This is going to be FG equals M. All right, now I don't have G by itself yet. I need to divide FG by capital F, by the fuel economy. So I find that G equals M over F, which is the same in this case as 350 miles over 28 miles per gallon. The gallons of fuel she needs are 12.5 gallons. All right, that's how you work these sorts of problems. It's handy to set up the equation, getting the thing you're looking for on a side by itself first, and then plug in the values that you know to find the thing that you're looking for. Or some problems just have you get the thing you're looking for on a side by itself, and you still have variables in your equation that you need to just include in your final expression, your final equation. All right, that's how you do this. You should be able to work numbers 1 through 30 in the new lesson.